Have you ever pondered the question, where are the aliens? In the grand theatre of the cosmos, we find ourselves on a tiny stage, dwarfed by the magnitude of the universe that stretches out almost infinitely all around us. Boundless, it holds an incalculable number of galaxies, each teeming with countless stars. Around these stars, a myriad of planets whirl in an intricate dance of gravity and motion. From the smallest dwarf planet to the largest gas giant, each celestial body is a testament to the universe's infinite variety and potential for life. The sheer scale, the mind-boggling numbers, they all lead us to an inevitable question. Are we the only conscious beings in this vast cosmic ocean? Are we truly alone in this expansive universe? We've been looking, searching the stars, listening for signals, for any hint of life beyond our own. Yet, despite our ceaseless search, we remain seemingly alone. Why is that? To understand our solitude, we must first look to the Drake equation. This intriguing formulation proposed by Dr. Frank Drake in 1961 serves as a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The equation considers several factors: the rate of star formation in our galaxy, the fraction of those stars with planetary systems, the number of planets that could potentially support life as we know it, the fraction of planets where life actually develops, the percentage where intelligent life evolves, the fraction of civilizations that develop technology that releases detectable signs into space, and the length of time such civilizations release detectable signals. The equation doesn't provide a precise number, rather a range of possibilities. But even at its most conservative, it suggests there should be a multitude of civilizations out there. With such a high probability, why haven't we heard from anyone out there? This brings us to the Fermi paradox. Named after physicist Enrico Fermi, this paradox is a contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. Imagine the universe as an ancient, expansive forest. There are countless trees, each representing a galaxy, and each leaf on those trees symbolizes a star with potential planets. Given the sheer size of the universe, the law of averages would suggest that some of these planets should harbor life. Yet, despite decades of searching, we found no sign of extraterrestrial civilizations, no hello messages, no space probes, nothing. This silence is deafening and perplexing, leading us to question, are we truly alone? The Fermi paradox doesn't provide an answer, but rather poses a question that deepens the mystery of our cosmos. It's a cosmic conundrum that continues to baffle the brightest minds. So, if there are a multitude of civilizations, where is everybody? One theory proposed to answer this is the Great Filter. This concept, in essence, represents a hypothetical barrier that prevents civilizations from colonizing the galaxy. It's a wall that stands between life as we know it and the kind of advanced civilization we've yet to become. The Great Filter theory suggests that at some point in the evolutionary journey of a civilization, it hits a roadblock so significant that it wipes the civilization out entirely. This could be anything from global nuclear war to climatic catastrophe to a deadly pandemic. If this theory holds true, then the reason we haven't discovered any other civilizations may be because they've all hit their Great Filter and didn't survive it. For us, this theory holds a chilling implication. Could we have already passed the Great Filter, or is it looming in our future? If it's the latter, our continued existence could be a ticking time bomb, waiting for that fateful filter to strike. Another theory to consider is the zoo hypothesis. This cosmic conundrum suggests that we humans are essentially living in a zoo or wildlife sanctuary of sorts. But who are the zookeepers, you may ask? Well, these would be advanced extraterrestrial civilizations silently observing us from a distance. The zoo hypothesis proposes that these civilizations are consciously avoiding direct contact with us, choosing instead to study and observe our society in its natural state, much like we observe animals in a zoo. They might be curious about our development, our cultures, our technology, and even our propensity for self-destruction. This theory is quite intriguing because it flips the question on its head. It's no longer a matter of why haven't we found them, but rather, why haven't they revealed themselves to us? Is it out of respect for our autonomy or fear of our reaction? Are we simply an intergalactic zoo exhibit? Then there is the rare earth hypothesis. This intriguing proposition puts forward the idea that the conditions necessary for life as we know it are incredibly rare in the universe. It's a perspective that shifts our gaze from the vastness of space to the extraordinary uniqueness of our own planet. Imagine, if you will, a cosmic lottery, each planet a ticket, each star a possible jackpot. But the odds? Astronomically high. The rare earth hypothesis suggests that the winning ticket requires a perfect storm of conditions. A stable star, a planet in the Goldilocks zone, a magnetic field to ward off solar radiation, plate tectonics, and the list goes on. Each condition is a filter, each one narrowing the odds of life. In this grand cosmic casino, the rare earth hypothesis posits, Earth might just be the lucky jackpot winner. So we are driven to ponder, could Earth truly be a cosmic rarity? Another intriguing idea is the transcension hypothesis. This hypothesis is a fascinating take on the question of where are all the aliens? It suggests that advanced civilizations don't just vanish, but they transcend, they move beyond the boundaries of our known universe, hence becoming undetectable to us. But what does this mean? How does a civilization transcend our universe? The transcension hypothesis, proposed by futurist John Smart, suggests that as a civilization reaches a high level of technological and scientific development, it begins to create its own miniature universe, often referred to as a black hole, where it can manipulate and control the laws of physics to its own advantage. This transition to a self-created universe is driven by the unending quest for efficiency and computational capacity. As civilizations advance, they would need to overcome the constraints of space and time. Creating their own universe allows them to do so, providing infinite computational resources and the ability to manipulate time. This would give them an almost godlike power, the ability to explore the very fabric of existence. However, this process of transcension would make them virtually invisible to us. Why? Because they would exist within their own black holes, isolated from our universe. They would be undetectable, not because they are hiding or because they have been wiped out, but because they have moved beyond our dimensions, beyond our ability to perceive or interact with them. This hypothesis, while purely theoretical, offers a fascinating possibility. It suggests that the universe may be teeming with advanced civilizations. Civilizations so advanced that they have moved beyond our comprehension, beyond our universe. We are like ants trying to understand the internet, limited by our own perspective and understanding. So the next time you gaze up at the stars and wonder where all the aliens are, remember the transcension hypothesis. It's a humbling thought, isn't it? Advanced civilizations might not be far away, out in the vastness of space. They might be closer than we think, hidden in dimensions beyond our own. Have civilizations gone unnoticed simply because they've left our dimensions? The search for extraterrestrial life raises more questions than answers. Each theory we've explored today, from the Drake equation to the transcension hypothesis, offers a unique perspective on the enigma of our cosmic solitude. The Drake equation, for instance, presents a mathematical approach to estimate the number of civilizations in our galaxy with whom we might communicate. Yet, the vastness of the universe and the variables within the equation make it a complex and uncertain tool. Then there's the Fermi paradox, a conundrum that points out the contrast between the high probability of extraterrestrial life and the lack of evidence or contact. This paradox leads us to the concept of the Great Filter, a hypothetical barrier that prevents civilizations from colonizing the universe, suggesting that we might be alone after all. Alternatively, the zoo hypothesis suggests that we're not alone, but rather we're being observed and kept in isolation by advanced civilizations. The rare earth hypothesis, on the other hand, argues that the conditions necessary for intelligent life are incredibly rare in the universe. Lastly, we delved into the transcension hypothesis, which proposes that advanced civilizations invariably leave our universe, reducing their direct visible impact on the universe, giving the appearance of absence. Each theory, each hypothesis adds another layer of complexity to our understanding of the universe and our place within it. The search for extraterrestrial life is a journey of exploration, curiosity, and continual learning. It's a quest that pushes the boundaries of our knowledge, technology, and imagination, stretching us beyond our terrestrial confines. So, while we may not have found the aliens yet, the search itself is of immeasurable value. It compels us to keep looking, to keep asking, to keep exploring. Each question leads us to new discoveries, new possibilities, and a deeper understanding of the universe and ourselves. While the question, "Where are the aliens?" remains unanswered, it beckons us to continue our quest for knowledge in this vast unexplored frontier we call the universe. It's a question as old as time itself, and one that continues to captivate us. This cosmic inquiry has been the driving force behind many of our greatest scientific advancements, pushing the boundaries of human knowledge and understanding. The universe is vast, almost beyond comprehension. It's filled with countless galaxies, each teeming with billions of stars. Within this grand cosmic theatre, could it really be possible that Earth is the only stage where the drama of life unfolds? The odds seem astronomical. In the grand scheme of things, our home planet is but a small speck of dust in an endless cosmic sea. But it's a speck that may hold the key to one of the universe's greatest mysteries. Is there life beyond Earth? The search for extraterrestrial life has fascinated humanity for centuries, and today we journey through this quest. The quest for alien life began with our early ancestors, who looked up at the stars with wonder and curiosity. Our story starts thousands of years ago with ancient civilizations who gazed at the night sky and pondered the mysteries it held. They saw patterns in the stars and created stories to explain them, often attributing them to gods, spirits, or otherworldly beings. The ancient Greeks, for instance, believed in celestial deities residing on Mount Olympus, but also speculated that other worlds could harbor life. Their philosophers, like Thales and Anaximander, postulated that the universe was infinite and filled with other Earth-like worlds. Similarly, the Mayans, with their advanced knowledge of astronomy, believed in the existence of other realms, both in the heavens and the underworld. In India, the concept of extraterrestrial life was not unfamiliar. Ancient Hindu scriptures describe a universe teeming with life, including beings from other planets. Meanwhile, in China, the philosopher Zhuangzi dreamed of a cosmos filled with different levels of existence, some of which might be inhabited by other forms of life. Fast forward to the Middle Ages, and we see the emergence of more scientific theories. The philosopher Giordano Bruno envisioned an infinite universe filled with a multitude of worlds and possibly a multitude of life forms. However, his ideas were considered heretical at that time, illustrating the clash between early scientific thought and prevailing religious beliefs. The Age of Enlightenment brought a new wave of thinking. Immanuel Kant and William Herschel, among others, proposed that the universe was populated with a multitude of planets, many of which could potentially support life. The seeds of the modern search for extraterrestrial life were thus sown. As we advanced, so did our understanding of the cosmos and our place within it. Our early ancestors could only dream and speculate about the universe. Today we are actively searching for signs of life beyond our planet, armed with the knowledge and tools that centuries of scientific progress have provided us. But that initial sense of wonder, that fundamental question of "are we alone?" remains as potent as ever. The birth of modern astronomy gave us new tools to explore the universe and seek answers. With the advent of telescopes, we were able to gaze into the cosmos like never before. These instruments of discovery allowed us to see beyond our own world, revealing a universe teeming with celestial bodies. As we peered further into the abyss, we discovered other planets within our own solar system: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. Each one unique and different, yet they all stirred up the same age-old question: could there be life out there? The possibility of life beyond Earth was no longer a mere flight of fancy. It became a scientific question, one that required evidence and systematic exploration. The universe was not just a celestial sphere dotted with stars, but a vast expanse full of potentials and mysteries. These discoveries only fueled our curiosity, and the search for extraterrestrial life intensified. The space age brought about a new era in our quest for alien life. This was an era marked by the launch of satellites and space probes, each one a leap towards the uncharted territories beyond our blue planet. These vehicles of exploration, brimming with scientific instruments, were hurled into the dark abyss, their mission to search for signs of life beyond Earth. The 1960s saw the birth of the SETI project, an acronym that stands for the Search for Extraterrestrial Intelligence. This ambitious project aimed to detect signals from intelligent life forms outside our solar system. Giant radio telescopes were erected, their dishes pointed towards the heavens, listening for a whisper, a beep, or any sign of life amidst the cosmic noise. These telescopes scanned the sky, collecting data from thousands of star systems. Each star, a sun to its own solar system, held the potential of harboring life-sustaining planets. SETI's mission was not just to find extraterrestrial life, but intelligent life. They hunted for signals that indicated not just existence, but communication, technology, civilization. Yet the search was not easy. The vastness of the cosmos is almost inconceivable. There are billions of galaxies, each one home to countless stars. And around each star there could be planets, moons, asteroids and comets. The quest to find a needle in this cosmic haystack seemed daunting, yet we persisted. We sent probes to our neighboring planets, rovers to Mars, and satellites beyond the edges of our solar system. We peered into the depths of the cosmos with our telescopes, hoping to catch a glimpse of something, anything that might hint at the existence of alien life. Despite our best efforts and advanced technology, the question remained, where are the aliens? The silence from the cosmos was deafening, but it did not deter us. It only fueled our curiosity, our determination, our resolve to continue the search. For in the grand cosmic theatre, it seems unlikely that Earth is the only stage where the drama of life unfolds. The discovery of exoplanets has opened up new possibilities in our hunt for extraterrestrial life. These celestial bodies, planets beyond our solar system, orbiting around other stars, have transformed our understanding of the cosmos. The concept of exoplanets was purely theoretical until the late 20th century. The first confirmed detection came in 1995 with the discovery of a gas giant orbiting a star called 51 Pegasi. Since then, our knowledge has exploded. We've identified over 4,000 exoplanets in our galaxy, the Milky Way, and there are likely billions more waiting to be found. Central to our search for extraterrestrial life is the concept of the habitable zone. This is an area around a star where conditions might be just right for liquid water, a key ingredient for life as we know it to exist on the surface of a planet. Not too hot, not too cold, but just right. It's often referred to as the Goldilocks zone. The hunt is on for Earth-like planets within these habitable zones. These planets would be of similar size to our own and orbit a star similar to our Sun. The Kepler Space Telescope, launched in 2009, has been instrumental in this quest. Kepler has discovered numerous potentially habitable worlds, including Kepler 22b, the first confirmed planet found within the habitable zone of a Sun-like star. But the search doesn't stop there. The Transiting Exoplanet Survey Satellite, or TESS, is now on the hunt, scouring the cosmos for planets around the nearest and brightest stars. And the James Webb Space Telescope, set to launch soon, will allow us to peer deeper into these exoplanets, studying their atmospheres for signs of life. Our quest has led us to discover thousands of exoplanets, some of which could potentially harbor life. We are on the brink of an exciting new era, as we continue to explore these distant worlds and seek answers to one of humanity's most profound questions. Are we alone in the universe? Today, the search for extraterrestrial life continues with renewed vigor and hope. Across the globe, scientists and researchers are tirelessly probing the cosmos, armed with cutting-edge technology and a thirst for knowledge. Current missions like NASA's Mars 2020 rover and the European Space Agency's ExoMars project are meticulously combing our neighboring red planet for signs of past or present life. Meanwhile, the Kepler Space Telescope, even in its retirement, has left us with a legacy of over 2,000 confirmed exoplanets, some of which reside in the habitable zone of their star. More recently, the Transiting Exoplanet Survey Satellite, or TESS, has taken up the mantle, discovering over 100 new exoplanets in just its first year. And let's not forget the James Webb Space Telescope, poised to launch soon. With its unrivaled power, it's expected to uncover even more about our universe's potential for life. The universe is vast and mysterious, and our search is far from over. Our journey through the cosmos and the search for extraterrestrial life is a testament to human curiosity and perseverance. We've traversed the expanse of history, from early observations and theories to the birth of modern astronomy. We've explored the space age and the search for extraterrestrial intelligence, a quest that has only intensified with the exoplanet revolution. The hunt for habitable worlds has opened new possibilities and expanded our understanding of life's potential beyond Earth. Today, we stand on the precipice of discovery, with the current state of the search more promising than ever. Each new observation, each new theory, each new world discovered brings us a step closer to answering the question that has captivated us for centuries. As we continue to gaze up at the night sky and wonder, we remain hopeful that one day we will find the answer to the cosmic question: are we alone in the universe?